Was that supposed to be suggestive?
Super stupid. Yeah, I was trying
Hope that was so
to
stupid.
like the innuendo in that.
Just kidding, it wasn't terrible.
You could go away.
Yeah, it was awful.
That could be a problem.
And the video's on.
Of course.
She keeps S-ing the function.
Okay, so integrals is like the second half of
F-ing the
calculus.
function?
And there's two kinds. There's a definite integral. What?
Did you ever post that video of you saying that word where...
It's in there somewhere. It's I didn't even do anything with it.
Because I
Yeah.
have it in my ring.
But you gotta go find it. Like you gotta go find where it had. I don't even know.
I'm gonna mold all
I did leave it on.
make something.
Anyway, there are definite integrals and there are indefinite integrals. You will be doing definite at first, and all definite means is you have a start and an end to an integral. So the way this would read is the integral of f of x from a to b with respect to x is one way it would read, or the integral from a to b of f of x with respect to x. This just means with respect to x. It's just a notation that people hate and it confuses them, but it really doesn't need to. It just means that the variable that you're dealing with is x. And it's just a notation, almost like, you know how when we take derivatives, if we had y equals 2x, the derivative of y is 2, technically dx. We don't have to add that on because we know that the derivative of that is just 1. It's the same thing, they're just putting the dx in. So it's like, it's just a notation that you really don't need to worry about, but you do have to have it there. And anyway, the broad definition of an integral is it's the area beneath a curve. It's the area underneath a curve from the curve to the x-axis. So, broad definition. And really, it just is the definition, actually. An integral is the area under a curve. Oops. In this case, f of x from x equals a to x equals b, from the letters that I'm using.
In the original function or in the integrated function?
Integral function, in the original function. So, for example, if you have to take the integral of x with respect to x from 0 to 3, all that you have to do is take a look at the function y equals x. It's the line, goes to the origin. Go from 0 to 3 and find the area of that space. Now, who's done integrals in physics already? Okay, integrals. But do you talk about them as area under a curve, or is it more as antiderivative?
More
area
and.
under a curve? Okay, and that's what we're going to do tomorrow. Today we're all going to have functions that you can take the area of. So this is obviously a triangle.
Wait, it's above the x-axis always?
Above the x-axis. It doesn't go down to like infinity, it stops at the x-axis. So I'd be taking the area of this little triangle. So it would be 1/2 times the base of the triangle times the height. The base is 3, what's the height?
3.
Also 3. So the integral is 9/2.
So definite integrals are things with triangles, I guess.
Not with triangles. Definite integrals are just things that have a concrete, no, not even a concrete answer, but that go from one place to another, and in other words, it's not the whole number line. So if it's definite, it means I'm going from 0 to 3. You can have indefinite integrals that just mean something different.
Okay.
Integral is the opposite of a derivative.
There's another definite, yes, it is also that. We'll get to that. It's actually both, and it's going to blow your mind.
Below it?
It is.
Is it both at the same time?
It's both at the same time.
Yeah. It's crazy.
It is.
Yeah.
Everything else you know about integrals is still true.
Boom.
So if you know what an antiderivative is, it's the same thing, but just wait.
What?
Let's do this one. Just for fun. So if you have to take the integral of 5 dx, the dx is just a notation. I'm talking about what's the area under the curve. I use the word curve to explain everything, even if it's a line, of y equals 5. So y equals 5 is just a horizontal line at 5. And I'm going to go from -2 to 3. So I kind of draw little vertical lines just to show myself what area I'm talking about and what is the shape that's formed. It's a rectangle, and the area of it is going to have a height of 5 and a width of 5. So this integral is 25.
Yay. This is very exciting.
What's that?
Very exciting.
It is. It's exciting. Okay, right? Okay, so we're a little bit limited in what we can take the integral of because we don't have that many formulas. Like we don't know what the area under a parabola is or the area under a cubic function is or any of that stuff. So that limits us a little bit. In addition to this, there's something else you need to know.
Not the first example.
Yeah.
It didn't start at 0, but at -1, would it just still be 9 halves, or would you have to subtract?
You can subtract the other, and that's what we're going to do right now. Okay, there's a couple rules. The two that we just looked at, everything was above the x-axis, and it was a nice little shape, but it was more importantly above the x-axis, so all of our areas were positive. Unfortunately, it doesn't always work that way. Say I have just some kind of curve like this. Any area under the x-axis is actually going to be negative, usually. So,
It cannot be positive.
it can, I guess I'm saying. Area under the x-axis is negative. And area above the x-axis is positive. So when we talk about integrals, we're talking about net area. So the negative and the positive can undo each other. You can sometimes have the integral of something that has space, but the integral of it is actually 0. Can anyone think of an example? Cosine. Okay, cosine and sine are great ones to kind of model this. If I take the sine of x, or the integral of the sine of x dx, what should I go to? From what to what to give me an area of 0? 0 to 2 pi. Okay, sine, remember, looks like this. This is 2 pi here. This is pi. So if I go from 0 to 2 pi, my area is going to be 0. Without even knowing how much area there is in these two humps, I just know that it's the same. So the amount on top and the amount on bottom undoes itself. Even if I said the integral from -pi over 2 to pi over 2. Even if I don't have a complete hump, but I go from -pi over 2 to pi over 2. If I'm talking about this and this, I know that it's equal on the top as is on the bottom, so that integral is 0.
That's really weird.
Okay? There's going to be a difference between an integral and area. If they asked you for total area, and they might, but we'll get to that. If they said, what's the total area between this curve sine x and the x-axis, that would be different. Then whatever this is would be an amount that's positive, and this would be an amount that's positive when we put them together. But if they're asking for the integral, they want area underneath to be negative and area above to be positive.
I don't understand.
What is above the x-axis?
It's between the curve and the x-axis. It's just in the first two examples, it happened to be above.
I don't understand how the integral can be 0 when sine x is the derivative of negative cosine x.
I don't want to go through the antiderivative way yet, but we will.
Okay.
Okay, if you took an antiderivative and did what you're supposed to do with that, you'd get 0 also.
Yeah.
Okay.
Okay.
All right, so we said area below is negative, area above is positive. That's only if you're going left to right, which you usually do, okay? If you're going left to right, that's true. If you are asked to go the other way, then everything changes sign. So I'll write it. If you go right to left, everything changes sign. Sorry. So like, let's just say we went the integral from 5 to 0 of, well, there's not a whole lot we can do here, so I'll just say x again to keep it easy. Not even 5 to 0. What did we just do? We just did 0 to 3 in the first example. We'll go 3 to 0. So if I had this problem, it's still the line y equals x, and it's still like 0 to 3, but I'm going backwards. Oh, I should have told you.
I guess it makes sense if you're always subtracting the bottom from the top.
Right. These are called limits of integration, by the way. I should say that. These things are called limits of integration. They're what you're taking the area from one to the other. And we always read it bottom to top. So on this first one, we were going from 0 to 2 pi. Then we were going from negative pi over 2 to pi over 2. Now I'm going from 3 to 0. Well, I'm going from positive then to the left. So I'm going from right to left instead of left to right. Think of it as you read. Okay? If you're going the way you read, which is what you usually go, underneath is negative, above is positive. But if you switch and you go backwards, then the signs change. So what is this integral? Negative 9 halves. I didn't do that in my head, it's just that was the first example we got, it was 9 halves. So now if we're going to go backwards and go from 3 to 0, it's going to be negative. Did you get that? Okay. Alright, so if I'm going to write the rules a little more officially, there's just a couple of things. So just a few things are, if we integrate from A to B, that would be the opposite sign if I integrated from B to A of the same function. So this is what I just said. Usually I go from left to right, but if I change that and go from right to left, it's going to become the opposite sign. Not to confuse you more. A, B, C. Let's say this area is 6 and this area is 7. What do you think the integral from B to A would be if this is f of x?
6. 6.
Negative or positive?
Positive.
Positive. Because if I go from B to A, I'm going backwards. It's below, so it's negative, but crap, I'm going backwards, so it's actually positive. I did. Do you get that? So as long as I'm going left to right, if I was going from A to B, it would be negative 6, B to C would be positive 7. But once I turn backwards, C to B is going to be negative 7, B to A is going to be negative 6. Okay. In addition, if we have the integral from A to C, this is going to equal the integral from A to B plus the integral from B to C. Which this one's kind of obvious. I'll write down next to it. Okay, it's just a rule that I don't know, I feel like I should put it up just in case. But if you do add 2 pieces, it would equal the whole. So
it doesn't get any harder than this, right?
the integral in this case from A to C is going to be what?
13.
No,
Huh?
1.
I don't know.
Okay? When I talk about integral, I'm talking net change. So if I'm going to go from A to C.
Oh wow.
What was that?
Oh.
It doesn't get any harder than this.
If I'm going to go from A to C, I'm going left to right. So this much is actually -6 because it's below the axis. This much is 7 because it's above. Put that net change together and I get 1. Okay? Maybe it's not so duh after all.
No, it is. That was just me.
Also, this one's kind of silly, but whatever. If I have the integral of k, f of x, let's say from b to c. If I have a constant in front of my function, that constant can come out to the front. So this can just be k times the integral from b to c. That might not seem helpful now, but it will be later, so we'll be referencing it again. Okay, and it's only if you have a constant. If you have two functions multiplied, you can't just pull one out. But if you have a constant, you can pull out that constant. Let me make sure I got everything. Yeah. Yeah, okay.
Taboo.
A couple more. Any questions so far?
Where's half the class?
Knowledgeable.
Then where's half the class?
She just said they're knowledgeable.
We wanted to hear it from you.
Okay, separate problems, they have nothing to do with this picture. The first one, what is that shape?
It's a U. Isn't it?
A U? Half circle, semicircle. It's a half circle. So remember,
Only the
like,
bet it's a
if
U.
x squared plus y squared equals 4, that would be a circle with a radius of 2. That's basically the same thing. This is like saying y equals the square root of 4 minus x squared. So if I square both sides, it'd be y squared equals 4 minus x squared. So x squared plus y squared equals 4.
Looks like a U to me.
It doesn't come up very often because circles aren't functions. But if I have just the positive square root, I'm just talking about the top half, so it is a function. And it comes up now because it's one of the few things you actually can take the area of without some crazy weird formula. So this is just a circle with a radius of 2. And I'm supposed to take the area from -2 to 2. So I'm just looking for this. So I should take the area of a circle and divide it in half. So 2 pi. Questions about that? Alright, hold on, don't go. Let's do one more like this. Alright, what if you have this one?
Bring the -1 out to the front.
So you can do a couple different things. First of all, it's negative, which means what part of the circle is it? It's the bottom, so I could just graph it and graph the bottom instead of taking the negative out. It's the bottom half of a circle.
If it's negative, could you just flip the two numbers?
What, these two?
Yeah, get rid of the negative.
I could. I could do both. Take the negative out, like, get rid of it, not just take it out, right? Yeah, and flip the numbers, sure. So I get the bottom half of the circle, but I'm also going from 0 to -2. So I'm going backwards, and it's just this much. First of all, what sign will your answer be? Positive or negative? Positive. I'm going backwards, and I'm underneath. So usually when I'm underneath, it's negative, but because I'm going backwards, it's back to positive. And knowing what that was, how much is this? Just pi.
Just for shiggles, would you show me what the equation of the integral is?
What do you mean?
Like, if I, whatever that's the derivative of.
That I don't know that I could do in my head. I don't know if I could do it period.
I was gonna say because
You can't take the antiderivative of that.
that's what I thought.
Yeah, you can. When we get to antiderivative, there's only like, they say 10% of all functions we can actually find their antiderivative. There's like a ton that you
Yeah, there are so many that I look at. I'm like, I would need chain rule
We'll come
or
up with
something.
techniques for it, but there still are a lot that we can't do. Alright, last one. So we're gonna throw some variables in
You know,
there.
I need, like there would need to be a 2x next to it.
Yes, to do it by substitution. Okay, so this is the function y equals x, so it's a line. And I'm going from 0 to b. And the question is, what's the area? So you're going to have a couple of these with variables in it where your answer is going to be in terms of b. Well, I know it's a triangle, so I know it's 1/2 times base times height. How big is the base?
B,
B, and how big is the height?
B.
B. For people who are a little unclear, this probably was too easy, but all I'm doing to find the height of this is I'm plugging b into the function y equals x. And that's giving me the height. So I plugged that in and got that. So I got b squared over 2. As a side note, I forgot sometimes you're going to need the area of a trapezoid. Like what if I went from like A to B? It was that much. Do you remember the area of a trapezoid?
1/2 base 1 base 2 plus base 2 times height.
That's the area of a trapezoid. You need that.
A trap. It's a trap.
So what's so weird about that? Okay, so we need the homework on
You know,
paper.
Luke would know if he were here.
I get it.
Okay. You do?
What?
I'm kind of surprised.
I did think.
Yeah.